Hello everyone, hope all of you are doing good. This is coming back with the second presentation of ocular anatomy and physiology. Today we'll be discussing about anatomy of the uvea. In this lecture we'll be learning about what are the anatomical structures of the uvea, or anatomical structures of the parts of uvea. Okay, what are the different parts of the uvea, and also to understand the different functions of uveal parts. Okay, we have already discussed and we already know what are the parts of uvea. There are three basic parts which we'll be discussing in the next slide. The anteriormost part is the iris, then the ciliary body, and the choroid that is lining the whole of the back of the eye, and that choroid is located between the sclera and the retina. Alright, it is clear now. Uvea is a middle vascular coat of the eyeball. So in this picture, let me just take my laser pointer. Okay, so in this picture, whatever you are seeing in red color, okay, that is that is our uvea. Okay, so we are already clear about right. The uvea is a middle vascular coat of the eyeball. Okay, vascular coat is nothing but it has rich blood vessels, and we have discussed in the previous classes why the uvea has rich blood vessels, because uvea is the one that is basically supplying blood inside the eye. Okay, right, and it is sitting behind the retina so that it can give sufficient blood supply to the retinal layers, right? And we discussed why the retina has to get oxygen and the nutrients so much in good amount, because for the retinal cells and photoreceptor cells and all other retinal layers to function, it requires oxygen and nutrients. So that is the basic function of the choroid here, right? And as I mentioned, from the anterior side, it has this is the iris, and this is the ciliary body, and this is the choroid. Okay, so lining the back surface or back part of the eye. So it is easy to remember from anterior to posterior, or when you're writing you have to specify from which part or which side to which side, anterior to posterior or posterior to anterior. So how uvea got its name? Okay, so uvea, the meaning of it is grape, and you can have a comparison. Okay, it is, if you look at the uveal structure, okay, and it has a lot of similarity to a grape, and you can just take this as the pupil, and you can see that this part of the grape is little flatter. Okay, that is the iris one, and it is covering the whole part of the eyeball behind. So that is the reason the name uvea. Okay, so it has the shape of a grape, that is why it is known as uvea, and it is originated from Latin. Okay, so from this slide onwards, we'll be talking about different parts of the uvea. We'll start with the first one, that is the anterior-most part of the uvea, that is the iris, and you can easily see in this picture the colored part of the eye, that is the iris. Okay, so it is the anterior-most part of the uvea, and what is its basic function? It is forms like a diaphragm-like structure. Diaphragm is nothing but, okay, a curtain, okay, in front of the crystalline lens. So your the iris is working like a curtain in front of the lens, and we already know that lens is a bigger structure behind. When you remove the iris completely from the eye, we'll be able to see the whole part of the posterior part of the iris will be covered by the crystalline lens. So it is, and crystalline lens, we already know that, okay, it is the second most major refracting surface. The light rays has to get focused, or it has to get refracted after passing through the lens. So why it is acting like a diaphragm or a curtain? Because when we look into very bright light, it controls the light, and in the evening when the light from outside is lesser, it will uh, make the pupil size bigger so that more light can come inside. So there is a history of the name iris also. Okay, it is coming from, or it is originated from Greek word means rainbow. Okay, so why the iris resembles as a rainbow? Okay, because iris is the only or the one structure that decides the color of the eye. You can see so many different colored iris. Okay, and also it is depending upon the amount of melanin pigments in our body. Generally, Asian and Africans will have brown color iris. Depending upon the skin color, uh, um, the people from Africa has more dark skin, so generally their iris also will be much more darker. So, but if you take Asian and African population, you will be able to see brown color iris with different intensities of brown color. But when you go to Europe, those are known as Caucasians. They are generally light colored skin, so they will be having lighter color iris, and most of the time you will see this kind of colored iris in whites. Okay, so average diameter of the iris is 12 millimeter. Okay, vertically or horizontally. We already learned that. Okay, what is the vertical visible iris diameter and horizontal visible iris diameter when we learned about cornea, because this is the end of the cornea here, the end of the cornea, or the limbus here. So from limbus to limbus is the measurement, that is the diameter it's talking about. Average, it is not the exact one, average is 12 millimeter. All right, so iris is nothing but the one structure. Okay, it is connected to the ciliary body here, and this side is a pupil. Sorry, let me just take the laser pointer. Okay, so iris, this is a cross-sectional picture, right? Cross-sectional picture. This is the cornea, crystalline lens, zonules, ciliary body, and this is the sclera and the cornea. So iris is the structure that is dividing the anterior chamber into anterior and posterior chamber. So iris is the dividing structure, and at one side the iris is connected to the iris. So this part, sorry, iris is connected to the ciliary body. So this part of the iris where it is connected, okay, this part is known as the root of iris. Okay, so this part, right, okay, where the iris is connecting to the ciliary body, that part is known as root of iris. So nothing but root of the iris. So root of iris is the point where the iris is connected to the ciliary body. So in this slide we'll discuss about pupil. Okay, so pupil, as we already know, it is the central opening of the iris. We can have different size of the pupils. So generally the size of the pupil is 3 to 4 millimeter. Okay, general size is 3 to 4 millimeter. Okay, but the size, it changes from 1 millimeter to 9 millimeter. Okay, so depending upon the amount of light that comes in. So we already know the function of the pupil is to regulate the retinal illumination. The amount of light that is going into the retina is controlled by the pupil size. So a couple of terms you need to remember. Okay, one is meiosis, another one is mydriasis. It is nothing but constriction of the pupil is known as meiosis. Okay, so this is your meiosis, right? And this one, when the pupil is dilated, that is the mydriasis, right? Fine. So both the terms are new terms for you. You need to make sure that you learn it. Okay, so constriction means, the meaning of constriction is to become smaller. Dilation means it becomes bigger. So dilation means the diameter is more. In constriction, the diameter is lesser for the pupil. Okay, so try to remember both the terminologies. Pupil constriction is meiosis, pupil dilation is mydriasis. Okay, so average pupil size is 3 to 4 millimeter, and the pupil size can range from 1 millimeter to 9 millimeter. Okay. All right. So the size of the pupil, right? Sorry, we discussed about the size of the pupil in the last slide. Now we talk about the location of the pupil. location. Okay, of course the pupil is at the center of the iris, but not exactly at the center. It is slightly towards the nasal side. Now you can see that this is the temporal canthus here, this is the nasal canthus here, and the pupil is located slightly towards the nasal side. And as we discussed in the last slide, the pupil size is 3 to 4 millimeter normally. Okay, in this slide we'll learn a little bit more about the iris surface. Okay, so when we talk about topography is nothing but we're learning about the surface of the iris. Okay, you can already see it over here. This is the iris. Again, this iris is from a white person. That is why the iris is much more lighter in color. We have already discussed this. The average diameter of the iris is 11 to 12 millimeters. Okay, on an average it could be vertical or horizontal. And there's another new terminology which we need to remember now, that is the collarette. Okay, collarette, it divides the iris into pupillary zone and ciliary zone. Right, so iris has two zones, zone that is closer to the pupil and zone that is closer to the ciliary body. So this is the area closer to the ciliary body. We already discussed that in the previous slide, right? So iris is attached to the ciliary body, and this is the pupillary zone. Okay, so iris has two zones, the ciliary zone and the pupillary zone. Ciliary zone is nothing but the part of the iris that is close to the ciliary body connection. Okay, so collarette is the one that divides, or that is a junction between the pupillary zone and ciliary zone. You can see it over here. This is the pupillary zone, this is the ciliary zone. Both are separated by the collarette. Okay, so iris thickness is also not uniform. Iris is thickest at the collarette. Okay, so in this picture you can clearly see that, okay, there is a demarcation here. Okay, this demarcation is the collarette. Okay, and this is the pupillary zone. Right, so iris is thickest at the collarette, thinnest at the root of iris. So when a question is asking which part of the iris is thickest at the collarette. This is the part where the iris is thickest. Okay, and iris is thinnest at the root of the iris. All across the root of the iris is thinnest. Okay, where the iris is joining the ciliary body. Okay, so quick things to remember in this slide: diameter of the iris. What is collarette? It is nothing but the dividing zone between, or the dividing line between the pupillary zone and ciliary zone. Remember, the part of the iris close to the pupil is the pupillary zone, and the part of the iris close to the root of the iris, that is the ciliary zone. And iris is thickest at the collarette and thinnest at the root of iris. This is another slide that demonstrates the collarette. Okay, you can easily see that this is a part of collarette. Okay, you can easily identify it. Okay, so this part is the pupillary zone and this part is the ciliary zone. Okay, and especially in very dark irises, sometimes it will be very difficult, or sometimes it will be a little difficult to identify the location of collarette. But here we can easily see the collarette is, this is the area of collarette. Okay, pupillary zone and the ciliary zone. Okay, in the previous slide we saw what is the appearance from the anterior part of the iris. It is much more beautiful, but this is how the iris will look like when we look from the posterior side. Okay, when I say posterior side, you have to sit on the crystalline lens surface and look in front. Okay, so in the posterior side the color is different. It is much more brownish. Okay, and it is more uniform also, and it is darker than the anterior surface. It is much more darker, or much more dark brownish compared to the anterior surface. Okay, and we will learn more about the different muscles also in the upcoming slides. Right, so we are still discussing about the iris. Okay, and in this slide we'll discuss about the cross section of the iris. Cross section is nothing but, okay, this is the iris. When you cut across the iris, this is the cross section. Okay, this is the cross section of the whole eye, the cornea, ciliary body and lens. So when you cut across, so you just need to think like this, which is sitting a bit more magnified. Okay, so this is a cross sectional part. It has three areas: anterior limiting layer. Okay, so this one is anterior limiting layer. It is nothing but the anterior boundary of the iris. So whatever we are seeing from outside, the colored portion is anterior limiting layer. What is the second part? The iris stroma. We'll be discussing about iris stroma a little bit in detail. This is the iris stroma. Okay, this thicker portion is iris stroma, right? And the third one, that is a pigment epithelium, or the posterior most one. You can see here, you can see this epithelial cells with the nucleuses. Okay, two layers of epithelium are there. One is the anterior epithelium and another one is the posterior epithelium. So this is the location of the posterior epithelium and anterior epithelium. Okay, and that has the pigmented layer. That is why it is seeing much more brownish. And this is the anterior limiting layer. That means the anterior boundary, and the stroma here. Okay, so this, you can see it over here. This is the pupillary zone and this is the ciliary zone, and you can see the junction of pupillary and ciliary zone is the collarette. Okay, here we go. So in iris stroma, okay, we discussed in the last slide that iris stroma has the it is the thickest part of the iris. Okay, and I took the posterior view of the iris just to explain about the two different types of muscles. Okay, so iris stroma forms the main bulk of the iris. It is the thickest part of the iris, and it has muscles. Okay, two types of muscles. One is sphincter pupillae muscle, another one is dilator pupillae muscle, and it has blood vessels and it has nerves. So basically, blood vessels, nerves and muscles of the iris are located in the iris stroma. Okay, so we'll discuss about these muscles little bit. One is sphincter pupillae, another one is dilator pupillae. So now here we need to remember, pupil has two functions, right? When the light is more, it becomes smaller, right? Pupil constricts. When the light is less, pupil becomes bigger or dilates. So we need muscles to both of these function. To constrict, we need a separate muscle. To dilate, we need another muscle. So both of these muscles, okay, sphincter pupillae muscle and dilator pupillae muscle, are located in the iris stroma, sphincter and dilator. Okay, so from the name itself we can see that this is dilator pupillae muscle that is helping the pupil to dilate. So first we'll discuss about the sphincter pupillae muscle. Okay, right, so try to remember that. Okay, you have to learn the spelling of these muscles name. So what is sphincter pupillae? It encircles the pupil. Encircle means circulates or make a circle of the pupil. So your sphincter pupillae will be here, right, in the pupillary zone. That is a position of the sphincter pupillae, and yeah, it is located in the pupillary zone of the stroma. This, what is the function of this muscle? It helps the pupil to constrict. Okay, so what happens is this muscle will become active. Okay, and it is in the fashion of this sphincter pupillae is like a circular muscle. Okay, so if the pupil want to constrict, okay, the diameter of the muscle gets smaller and it constricts and pull the muscle towards the center, and the pupil becomes smaller. So next we'll discuss about the dilator muscle. Okay, dilator pupillae muscle. Okay, and what is the function of dilator pupillae? Okay, it needs to dilate the pupil, or it needs to increase the diameter of the pupil. We need to make the pupil size bigger. So these dilator pupillae are arranged in radial fashion. So can you see these lines, these white lines, like radiuses? Okay, so this is the dilator pupillae muscle. Okay, so it is like a radius. Okay, so it is recorded in a radial fashion, and it extends from the root of iris to the sphincter pupillae. Okay, so sphincter pupillae, it is an extended muscle, and this is the root of iris. It is extending from root of iris to the sphincter pupillae. So from the shape itself we can identify, okay, when the dilator muscle is functioning, it will pull the pupil, okay, it will pull the iris muscle towards the root of iris. So when the muscle pulls the iris towards the root of iris, what happens? The size of the pupil becomes bigger, or it becomes dilated. Okay, so when you go suddenly into the bright light, okay, at that time dilator pupil, because the pupil has to constrict, so the circular muscle that is present here, that is the constrictor pupillae or sphincter pupillae, will pull the iris towards the center, so that the iris becomes smaller. So it is easy to remember from the name itself. One is dilator one, another one is sphincter pupillae or constrictor pupillae. Right, so it has different blood vessels that we will be learning later when we talk about the blood supply of the whole eye, and it also has nerves that is required for this pupillary constriction and dilation. Okay, so we have discussed a lot of things about iris now, isn't it? Okay, we'll just quickly recap whatever we discussed about iris. Okay, so iris is the colored portion of the eye. Okay, and it has a central opening called pupil, and it has when we look at the topography of the iris, it has the collarette here. Okay, the ciliary zone, sorry, the pupillary zone of the iris and the ciliary zone of the iris. Okay, and also when we look at the cross section of the iris has an anterior limiting layer, and it has a stroma, and it has a brown epithelial surface. And when we look at the stroma, it has two types of muscles, sphincter pupillae and dilator pupillae. Dilator pupillae will help the pupil to dilate or mydriasis. Sphincter pupillae will help the iris or the pupil to constrict or miosis. Now in this slide we'll discuss about color of the iris. Okay, color of the iris is also not uniform, right? You can see a more brownish color, okay, much more something in between, and much more lighter and bluish. Okay, don't confuse that these are all natural pupils, right? Sorry, natural iris colors. These are not contact lens changed iris colors. Okay, look at this. In this you can easily see the collarette. Okay, you can see the collarette here, and also here you can see the collarette, the pupillary zone and the ciliary zone. So the color of the iris is depending upon the thickness of the anterior limiting layer. Okay, in the previous slide when we discussed about the cross section of the iris, the anterior most part is the anterior limiting layer. That is the area, okay, that is deciding upon the color of the iris. So if the thickness is higher, and also if the number of melanocytes, we already discussed that melanin is the one or the pigment that gives color of the iris. Now if you look at compare between 1, 2 and 3, it is easily understood this eye has more melanin pigmentation than this, and this one has the least amount of melanin pigmentation. So melanocytes are nothing but the cells that is producing melanin. So the number of melanocytes are more melanin pigments will be there, and the iris will have more brownish in color, because the melanocytes has the pigment density. Okay, if you have more melanocytes, there will be more pigments, and the color will be much more brownish. Okay, so in this eye the melanocytes are less, that is why this eye is looking lighter. And you can also have a look at their skin color. Their skin is also much more whitish, and you can see their eyelashes is also not black. Alright, in this slide we'll discuss something about something abnormal. Okay, a couple of disease conditions what we discuss. Okay, When you look at these two pictures, right, one here you can see this iris is, sorry, let me just take the laser pointer. Okay, this iris is much more lighter compared to this iris. So same person is having iris with two different colors. In this eye, if you observe, right, in the same iris you have two areas. This side is more brownish and this side is less brownish. Okay, these are disease conditions, okay, that happens to the iris. Okay, you will be learning about this more in detail in ocular disease classes. So this disease condition is known as heterochromia. Okay, the meaning of hetero is more than one. Okay, monochromatic and heterochromatic. Okay, mono means same one, hetero means multiple or more than one. So heterochromia is this disease condition. Chromia means color. Okay, chrome is color, that is why hetero, more than one color, that is the meaning of heterochromia. Now there are two types of heterochromia. You can see heterochromia iridum and heterochromia iridis. Now what is the difference between heterochromia iridum and iridis? This is iridum and iridis. Now heterochromia iridis is this one. Okay, what is that? In the same iris you have two different colors. Okay, so that is within the iris, within same iris you have two different colors. Now heterochromia iridum is when we are comparing between two eyes. Okay, the iris color between the two eyes are different. That is the meaning of heterochromia iridum. Okay, so try to remember these two terminologies. There are so many other disease conditions that is causing this difference in colors. Okay, so when you see a person with two different iris colors, okay, either in the same iris or between the iris, both are not normal. Okay, you can have similar iris color for both eyes, that is perfectly fine, but if you see two different iris colors in one eye or between right eye and left eye, if the iris color is different, both are not normal. Okay, in this slide we'll be discussing about ciliary body. So far we discussed about iris, okay, the anterior-most part of the uvea, that is iris. Now we come to the ciliary body. Okay, short form is CB, and it is clear from the picture. This is your iris, this is the root of iris. Root of iris is connected to the ciliary body. So this is the ciliary body. Okay, so it is the middle part of the uveal tissue. This is the anterior one, this is the ciliary body middle part, and from here on it is going as choroid. So it has three sides. One is a base, outer side, and inner side. It appears like when you take a section, when you take a cut section, it appears like a triangular section, or it appears like a triangular body, the ciliary body. Okay, it has the anterior, this base is towards anterior, this flat side is towards the sclera, and this side is, okay, pointing towards the posterior chamber. This is the posterior chamber. So it has a base, outer side, and inner side. So remember that when you take a section of the ciliary body, it gives a triangular shape, and this is the root of iris, okay, where the iris is attached. Right, so we'll discuss here about parts of ciliary body. Ciliary body has particularly two parts. Okay, one is pars plicata, second part is pars plana. Okay, so first we'll discuss about pars plicata. What is pars plicata? Part of the ciliary body which has ciliary process. What is ciliary process? Finger-like projections. Now you can see this is the ciliary body, right, and when you're coming this side, it has finger-like projections. These finger-like projections are known as ciliary processes. Okay, so pars plicata is the part of the ciliary body that has ciliary process. Now what is important about ciliary process? Okay, ciliary process is the place where aqueous humor is produced. Okay, so this finger-like projection is aqueous humor produced by ciliary process enter to the posterior chamber, and through the pupil it enters to the anterior chamber, and through the anterior chamber angle and trabecular meshwork the aqueous goes out. Okay, so that is about pars plicator. Remember that plicata is nothing but the structure that has finger-like projections. Those finger-like projections are known as ciliary process. Ciliary process is important. Why? Ciliary process is these finger-like projections are producing aqueous humor. Now the second part is pars plana. Okay, it says plana. That means it has a plane surface. So this part, right, this part is more like a plane surface. Okay, so that is why this is known as pars plana. Okay, and this part you can see like a finger like projection, that is a pars plicata. Okay, so what is pars plana? It is flat or smooth part of the ciliary body. Okay, remember both the names. Right, so we come to the final part of the uvea, that is choroid. Right, so we discussed about iris, we discussed about ciliary body, and now we are discussing about choroid. So from the picture it is very clear, right? What choroid, let me take the laser pointer. All right, so your iris, this is a ciliary body, right? And the choroid, so choroid is a longer one, right? And it is located between the sclera and the retina, that we already understand, and it extends from ora serrata to the optic nerve. Okay, ora serrata is here. Okay, so from where the retina starts, that is a point, is ora serrata. Okay, ora serrata here, and from ora serrata to the optic nerve, this is the optic nerve. Okay, ora serrata to the optic nerve. And you can see this is a picture, right? We already discussed about the retina, the photoreceptor cells, and each photoreceptor cells, you have rods and cones. Those photoreceptor cells are connected to the retinal pigment epithelium, right? This is the retinal pigment epithelium, and the retinal pigment epithelium is connected to the choroid. These are the choroidal blood vessels, and there is a membrane, okay, that is between the retinal pigment epithelium and the choroidal blood vessels. That membrane is known as Bruch's membrane. So you have one more name to learn now, Bruch's membrane, which we'll discuss a little bit more in the next slide. Alright, so we'll discuss about now parts of choroid. Okay, so choroid has basically four parts. One is lamina fusca, choroidal stroma, so choroid also has stroma. Iris has a stroma, so choroid also has a stroma. It has choriocapillaries. Capillaries means, capillary is nothing but, okay, capillaries is nothing but blood vessels. Okay, capillaries means blood vessels. Right, so choroidal stroma, okay, it has choriocapillaries, nothing but choroidal blood vessels, and Bruch's membrane. So try to remember all these four parts. Lamina fusca, okay, now you remember here, this is the sclera, this is the retina, and this brown one is the choroid. So what is lamina fusca? It is a connection between sclera and choroid. Okay, this is a sclera and this is the choroid in this picture, and this blue line is a lamina fusca. Okay, second part is choroidal stroma. Okay, it is a thick connective tissue, and here also it is thick and it has a pigmentation also. The third part is choriocapillaries. Okay, we already know that choroid is a bed of blood vessels. Okay, it is a huge collection of blood vessels. So choriocapillaries, it is a bed of blood vessels. And the fourth structure or fourth part is Bruch's membrane. Okay, we discussed that Bruch's membrane is the innermost layer of choroid that fuses with retina. Okay, so remember that at one side is sclera. Okay, the junction between choroid and sclera is lamina fusca. Junction between choroid and retina is Bruch's membrane. So in between lamina fusca and Bruch's membrane, you have stroma, and a bed of blood vessels. So those are the four parts of choroid which we need to remember. All right, so we are into the last slide of the uvea, or anatomy of the uvea. So we'll just quickly recap what are the functions of each parts of the uvea. Iris, we already learned that it is acting as a diaphragm, right? A diaphragm is nothing but a curtain to control the amount of light entering into the eye. Now, if you do not remember what is a curtain, we will just keep that curtain in front of or inside the window of our room so that the light from outside cannot come in. So iris is acting as a diaphragm to control the amount of light entering into the eye. Okay, so it is not only iris that helps, the pupil also, the size of the pupil, that is helping to control the amount of light coming inside. The second part we learned the ciliary body, right? So ciliary body, basically there are two functions. It produces aqueous humor. Okay, we learned that the ciliary processes in the ciliary body produces aqueous humor, and also it has ciliary muscle. Okay, the ciliary muscle that is helping us for accommodation. Okay, we learned about the process of accommodation because the ciliary muscle is connected to the zonules or suspensory ligaments. When the ciliary muscle contract and relax, the suspensory ligaments will control the change in power of crystalline lens. So ciliary muscle helps for accommodation, right? And choroid, right? Choroid has a couple of other functions. One, it provides nutrients to the outer retina. So we already understood the basic function of choroid is to provide nutrients and oxygen to the outer retina, because your photoreceptor cells is sitting in the outer retina. So these blood vessels will give support to the photoreceptor cells, and it also collects metabolic waste products from the retina through Bruch's membrane. Okay, Bruch's membrane is a junction between the retina and choroid, isn't it? So your choroid collects the metabolic waste products. Okay, there is a spelling mistake here. R is not there, it is waste products from the retina through Bruch's membrane. Okay, because a lot of waste products that happens in the retina, because retina is metabolically very active, because continuously it has to transfer the light energy into the neural signals. So photoreceptor cells is one of the location where a lot of photochemical reactions happens. Okay, so all those metabolic waste products are uh, collected by the choroid or choroidal vessels through Bruch's membrane. Why choroid is collecting? So that these waste products can be removed out of the eye through the blood. So that concludes our lecture on uvea. Okay, try to remember the cases, or try to remember the points what we discussed so far. Okay, from slide by slide as well as structure by structure. Okay, so I'm stopping now. We'll come back with another presentation within a short time.